Hello everyone, it's me. So today we're solving an interesting kinematic problem about a car that accelerates, moves at a constant speed, and then decelerates to a stop. By the end of this video, you will be able to break motion problems into clear and simple phases, use right kinematic formulas for each phase, and calculate the total distance traveled with confidence. So let's get started! Here's the problem. A car starts from rest, accelerates at 1 meter per second squared for 20 seconds, then travels at a constant speed for 30 minutes, and finally slows down uniformly to a stop in 30 seconds. Our task is to find the total distance covered by the car. To make this easier, let's divide it into 3 phases. Number 1, accelerating from rest. Number 2, moving at a constant speed. And number 3, decelerating to stop. Let's start with the phase 1 acceleration phase. So the givens are initial velocity equals to 0 meter per second, acceleration equals to 1 meter per second squared, and time equals to 20 seconds. What we're trying to find is the final velocity and the distance traveled. Let us proceed to step 1, finding the final velocity. We will be using the first kinematic equation, which is final velocity equals to initial velocity plus acceleration times time. So, let us substitute the values and the givens. Now, it will be final velocity equals to 0 meter per second plus 1 meter per second squared times 20 meter per second. Okay then, always start with the parentheses. 1 meter per second squared times the 20 seconds. It will be 20 meter per second. Now you have to plus that 0 meter per second to the 20 meter per second. The final velocity will be 20 meter per second. Step 2. Distance traveled during acceleration. Now we will be using the second equation of motion, which is position equals to initial velocity times the time plus 1/2 times acceleration times the time squared. Now let's substitute the givens. Position equals the 0 meter per second times 20 meter per second plus 1/2 times 1 meter per second squared times 20 seconds squared. Okay, now times all the parentheses. 0 times 20 equals to 0. 1/2 times 1 equals to 0.5. And if you square the 20, it will become 400. So now add it all up, which is 0 plus 0.5 meter per second squared times 400 seconds will equivalent to 200 meters. Phase 2, constant velocity. Now, after accelerating, the car continues to travel at constant speed for half an hour. This is the given data. Final velocity equals to 20 meter per second from phase 1's final velocity. We need to convert half an hour to seconds. We know that 1 hour equivalents to 3,600 seconds. Half an hour is 0.5 hours times 3,600 seconds per hour equals to 1,800 seconds. So our time is 1,800 seconds. Derivation. We will be using this equation to derive. Since the acceleration is 0, we'll be cancelling it out. Now our formula will be position equals to final velocity times time. Now let's substitute all of the givens. Position equals to 20 meter per second times 1,800 seconds. So our position will be 36,000 meter. Phase 3, deceleration. The givens are initial velocity is 20 meter per second. Final velocity is 0 meter per second and time is 30 seconds. But we have to find the acceleration. We will be using this formula. Now substitute the given. Negative 20 meter per second squared over 30 seconds equals to negative 0.667 meter per second squared. Now let's find the distance. Let us use this equation. Now substitute the given again. It will become 20 meter per second times 30 seconds plus 0.5 times negative 2/3 meter per second squared times 900 seconds. Now times all the parentheses. It will all add up to 300 meters. To sum all the distance from phase 1 to 3, the total distance would be 36,500 meters or 36.5 kilometers.